Here's a lesson for section 3.5, collecting like terms. Before we learn how to collect like terms, let's learn how to distinguish what like terms are. So let's define this first. Like terms are terms that have two things. Terms that have the exact same variables with the exact same exponents. So in order for terms to be like terms, they have to have the exact same variables with the exact same exponents. So I've got two terms here. So below here, I've got, in this box, I have an example of two like terms. And in this box, I have an example of two terms that are not like terms. So let's look at why these terms are like terms first. So I have 3x squared y and 15x squared y. So both of these have the exact same variables with the exact same exponents. This has an x squared. This has an x squared. This has a y to the 1. This has a y to the 1. So the variables are exactly the same, so the same letters, x and y, and those variables have the exact same exponents. X squared, y to the 1, y to the 1. Because those are exactly the same variables with exactly the same exponents, they are like terms. The fact that the coefficients are different, so remember coefficient is the number in front of the variables, the fact that the coefficients are different does not matter at all. Okay, so the coefficients have nothing to do with the fact to determine whether or not terms are like terms or not. So even though this is a 3 and this is a 15, that does not matter. That does not affect the fact that they are like terms. All we're looking for are the variables and the exponents on the variables to be the same. So let's look at this example. This one, the variables, they both have x's and y's, but in this case, this one has a y to the 1, and this one has a y to the 2. So the exponents are different. Therefore, they are not like terms. So even though they both have an x squared, this one has a y to the 1, this one has a y to the 2. So the exponents are different, so they're not like terms. Don't let the fact that they both have the same coefficient make you think they're like terms, because remember, the coefficients have nothing to do with determining whether two terms are like terms or not. So they've got different exponents on the y, so they're not like terms. So before we actually start simplifying equations by collecting our like terms, let's first make sure we're good at finding the like terms in a polynomial algebraic expression. So I've got 3x cubed. Let's look in this polynomial to see if there are any like terms to 3x cubed. So we want to find other terms that have the exact same variable with the exact same exponents. We need terms that have an x cubed. I've got a 2x cubed. Are there any other ones? And here's another one, a 12x cubed. So those three terms are like terms. I'll put a box around them to show that they're a group. All of those have the exact same variables with the exact same exponents. Okay? You might think because this term here, this negative 5x, that's got an x, shouldn't that be a like term? And the answer is no, because this x has an exponent of 1. So since the exponent on the variable is different than these ones, it is not a like term. Okay? Remember the definition of a like term? They have to have the exact same variables with the exact same exponents. Okay? So let's start a new group. So let's look at that negative 5x. Are there any other terms in this polynomial that have the same variable x with the same exponent, 1? So are there any other terms that have an x to the 1? Well, there's a 4x right here. And that's it. So there's a group. And then lastly, I've got a bunch of constant terms left. A 3, a negative 1, and a negative 120. Constant terms are always like terms to each other. So 3, negative 1, negative 120. Those are like terms. So those are the three groups of like terms that I have in this polynomial. Let's do another example. So in this polynomial, I got a bunch of terms separated by addition and subtraction signs. Let's group our like terms together. So I have a 5x squared y. Let's see if there are any other terms in this polynomial that have the exact same variables with the exact same exponents. Okay, so we need terms that have an x squared, y to the 1. I've got one here, 6x squared, y to the 1. So 6x squared y. And I've got another one right here, 4x squared y. So there's a group of like terms. Now, this negative 9xy is not like these ones, even though it has an x and a y as well. The x on this term has an exponent of 1, while the x on these terms have an exponent of 2. So they're not like terms. Okay? So let's find the terms that are like negative 9xy. So I've got negative 9xy. We need to find the terms that have the exact same variables with the exact same exponents. So we need terms that have an x to the 1, y to the 1. Here's one here, negative 2xy. And here's one here, negative 133xy. Negative 133xy. Okay, and what do we have left here? I still have the 17.3x. And are there any other terms that have an x to the 1, same variable, same exponent? Yep, there's a 92x. And that is all the terms taken care of. I'll put that box around the blue group as well. So those are all the terms put into groups with their other like terms. So remember, like terms have the same variables with the same exponents. So all the ones in this group are the same variables, same exponents, and same with this group and this group. Okay, now let's learn how to actually collect like terms. So when adding like terms, it's important that we don't get this confused with our exponent laws when we are multiplying and dividing terms. Okay? What we're doing now is we're adding and subtracting terms. That's what we call collecting like terms. So when adding like terms, we keep the variables the same. Keep the variables and the exponents on those variables exactly the same. Don't try and change those. And what we do is we just add or subtract only the coefficients. Remember, coefficients are the numbers in front of the variables. So if I want to simplify this expression here, first thing I'm going to do is I'm going to rearrange this expression, putting the like terms into groups beside each other. So I have a 6x and an 8x. Those are like terms because they have the same variable with the same exponent. I'm going to put those beside each other. So my 6x and my 8x. Put them beside each other. And then I also have a 4 and a 3. Those are constants. Those are like terms as well. So I put them beside each other. Plus 4, plus 3. Now I'm going to simplify all of my like terms. So I have a 6x. So if I have 6 x's, and then I add 8 x's to that group, I now have 14 x's. And then if I have 4 plus 3, well, I know 4 plus 3 is 7. So this simplifies to 14x plus 7. So you'll notice when I collected my like terms, when I did 6x plus 8x, I didn't change the variable or the exponent on the variable at all. I kept that exactly the same. I just added the coefficients. 6 plus 8 is 14, and I kept the variable exactly the same. So if you think about it, if you have a pile of 6 unknown things, and then you add 8 more of those identical unknown things to that pile, you now have 14 of those unknown things. Okay, so 14x plus 7. Let's practice collecting our like terms now. So if I have 3 x's, and then I add 4 x's, that is going to equal 7x. I didn't change the variable, I didn't change the exponent. When adding and subtracting like terms, you don't change the variables or the exponents. All you do is you add the coefficients. 3 plus 4 is 7. So 3x plus 4x is 7x. Next, now we have to be careful that we only add or subtract like terms. Okay? So I have a 3x squared and a 5x squared. Those are like terms because they have the exact same variables with the exact same exponents. This constant of 3 is not a like term to these two. So I can only collect these two together. And when I collect like terms, when I'm adding or subtracting, all I do is I add the coefficients. 3 plus 5 is 8. And I keep the variable and the exponent exactly the same. So I have 8x squared. And I still have that plus 3 off to the end. I can't collect it with 8x squared because these two are not like terms. Let's keep going. So I have 2b minus b plus 7 minus 8 plus 3b. So first of all, let's rewrite this by grouping our like terms together. So I have a 2b, a negative b, and a positive 3b. Those are all like terms because they have the exact same variables with the exact same exponents. So 2b minus, I'm going to write it as 1b. If I don't see a number in front of a b, I know there's a 1 there, plus 3b. And then 7 and negative 8, those are constants, therefore they are like terms. So I'll put those together at the end, plus 7 minus 8. So now, when I collect like terms, so when I'm adding or subtracting like terms, I keep the variables the same, the exponents the same. All I do is I add or subtract the coefficients. So I have 2 b's. I take away one of those b's, I'm now at 1b. I then add 3 b's, I'm now at 4. So 4b. So 2 minus 1 is 1, plus 3 is 4. So I'm now at 4b. I kept the variable and the exponents on the variable exactly the same. And now I can collect these like terms. 7 minus 8 is negative 1. So this term simplifies to 4b minus 1. Next one. Let's start off same way. Let's group our like terms together. So I have a 3x squared and a negative 3x squared. Those are like terms because they have the exact same variable, x, with the exact same exponent, 2. They both have an x squared. So 3x squared minus 3x squared, I'll put those together. And then I have a negative 6x and a 9x. Those have the exact same variables with the exact same exponents. I'll put those beside each other. Negative 6x plus 9x. And then lastly, my constant term always comes at the end. I have a plus 2. Okay? There are no other constant terms, so there are no like terms to that. I should also make a note right here. When you're writing a polynomial, okay, you want the highest degree terms to the left, and they should go in descending order to the right. Okay, so the degree of these terms these are second degree terms. They have a degree of 2. These terms here have a degree of 1, and this last term, the constant here, has a degree of 0. So this is in the proper order so far. Okay. So if you need help remembering how to define the degree of a term, go back and watch the lesson for section 3.4. So once again, I'll just state that one more time. When writing a polynomial, the order of the terms matters. You should have the highest degree terms to the left, and then they should go in descending order to the right. So like I said, these terms have a degree of 2, these terms have a degree of 1, and this has a degree of 0. So it's in the proper order. Now let's simplify by collecting like terms. So if I have 3x squared, and then I take away those 3x squared, I'm left with 0x squared. If I have negative 6x, and then I add 9x, well, what I remember when I collect like terms, so when I'm adding or subtracting like terms, I keep the variables the same and just add or subtract the coefficients. So negative 6 plus 9 is positive 3x. And I still have that plus 2 off to the end. And now I should simplify this further. 0 times x squared is just 0. So the x squareds are gone. All I'm left with is 3x plus 2. Good. So this big long expression here is just simply equal to 3x plus 2. Let's do some more. So I've got, well, let's make sure we put this in the proper order. So remember, I want the highest degree term to the left. So I see a negative 8x cubed. That's a third degree term. So I'm going to start with that one. That's the highest degree term. So I've got a negative 8x cubed. And I don't see any terms that have the exact same variable and the exact same exponent to that one. Okay. So now what I'm going to have, I'm going to see if there are any other like terms, any other groups of like terms. So I started with the term that has a degree 3. The rest of the terms here are all degree 2 terms, so it doesn't matter the order of those. So I've got a 2x squared. I'll just write that next, 2x squared. And there are no other terms that have an x squared, so there are no like terms to that one. Now let's try the negative 3y squared. Negative 3y squared, are there any like terms to that? This isn't, but hey, this one is, 2y squared, the exact same variable with the exact same exponent. So those are like terms, so I'll be able to simplify by collecting those two together. And at the end here, I still have a plus xy. So let's simplify by collecting the like terms. There's only one pair of like terms in here. I won't be able to simplify anything else. So I have a negative 8x cubed plus a 2x squared. And then I have a negative 3y squared plus a 2y squared. So simplify by adding or subtracting the coefficients. So -3 plus 2 is -1, and then keep the variable and the exponent exactly the same. And at the end, I still have a plus xy. Now we can't simplify this any further. We can't collect any of these together because none of these are like terms. None of them have the exact same variables or the exact same exponents. Let's do the next one. So we'll start with the highest degree term. So this term here is a degree 3. We'll start with that one. So I have an a squared b. A squared b. Are there any other terms that have an a squared b? This one right here. Here's another a squared b. So I have to add another a squared b. I'll put those together. Those are like terms. So those are done. Now, are there any other terms that have a degree 3? Those should come next. Yeah, so this one also is a degree 3, negative ab squared. Are there any terms that are like negative ab squared? Yeah, this one right here, a 2ab squared. So those are like terms. And what I have left, so I have 2ab, that's a degree 2, 2ab. Are there any terms that are like 2ab? Any other terms that have the same variable, same exponent? Yep, here's a negative 3ab. Negative 3ab. Okay, so I've got 3 groups of like terms. I'll be able to collect these groups together in order to simplify this expression. So if I have a 1a squared b plus another 1a squared b, that gives me 2a squared b. I added the coefficients only and kept the variables and exponents exactly the same. Now I have a negative ab squared plus 2ab squared. So negative 1 plus 2 is positive 1. And I keep the variables and the exponents the same. And then I have 2ab minus 3ab. So 2 minus 3 is negative 1. And then keep the variables and the exponents the same. So this is the simplified version of this polynomial. Okay, let's apply what we've just done. So I want to write an expression in simplest form for the perimeter of this shape. And I remember the definition of the perimeter of an object is the distance around the outside of an object. So I need to add all of these outside sides together, and that will give me an expression for the perimeter of the object. And I'll be able to simplify that expression. So this side is 18x plus 7. I need to add this side. That's on the outside as well. That side is 3x plus 5. I need to add this side. That side is 9x minus 2. I need to add the last side, which this little line here tells me it's the same as this side. So that's also 3x plus 5. So if I collect all these like terms, I'll be able to have a simplified expression for the perimeter of this shape. So I have, let's figure out what our like terms are here. So I've got an 18x, a 3x, a 9x, and a 3x. Those are all like terms. They've got the exact same variables with the exact same exponents. Let's write those beside each other so we'll be able to collect them. So 18x plus 3x plus 9x plus 3x. Now I have a bunch of constant terms left. I have a 7, a 5, a negative 2, and a 5. Constant terms are like terms, so I'll put those beside each other. 7 plus 5 minus 2 plus 5. And you'll notice these terms are in the proper order. All of these terms are degree 1. All of these terms are degree 0. So they go in descending order from left to right. That's good. Okay, let's collect the groups of like terms. So when I collect like terms, I just add or subtract the coefficients only, keep the variables and exponents the same. So 18x plus 3x plus 9x plus 3x. Let's figure out how many x's we now have. 18 plus 3 is 21, plus 9 is 30, plus 3 is 33. So I now have 33x. Now let's collect our constant terms together. 7 plus 5 is 12, minus 2 is 10, plus 5 is 15. So here's a simplified expression for the perimeter of that trapezoid. And let's evaluate that expression. So 33x plus 15. So perimeter equals 33 times x, which we know is 5, plus 15. So let's figure this out using the correct order of operations. So 33 times 15 will give us 165. And how I would determine that mentally, I would break this into 30 times 5 plus 3 times 5. Those are numbers that I would be able to multiply together. 30 times 5 will give me 150. 3 times 5 is 15. 150 plus 15 is 165. And I need to add 15 to that, and I figure out the perimeter is actually 180. And I don't think it gave us any units for this one, so the perimeter is just 180 units. Okay, so you'll notice that using this simplified expression, it was relatively easy to find the perimeter. Easier than if I substituted the 5 in for each of those x's and then simplified it. Okay, so the simplified expression was a lot easier to work with. Okay, if you have any questions, make sure you let me know.